Hello everyone. In this session we will discuss descriptive statistics and we will see how we can use Excel, Microsoft Excel to perform some of the basic descriptive statistics analysis. It's very important that we understand the underlying concepts first, as we will see later on. Using Excel or any software can make life much easier, but the key here is understanding the underlying concepts. With that, let us go to the slides. A normal data set will look very much like the graph that we see here. This is an example of students' grades, which is the horizontal axis here, and the vertical axis is the number of students. And it's bell-shaped, and we will discuss the normal distribution in more detail later on. But for right now, what we consider a normal data set is a data set that has few observations of the low values and few observations of the high values, and the bulk of observations or the majority of observations are in the middle. That's what we consider a normal data set. How we describe a normal data set? Well, the first thing we do is we need to be able to describe the center of the normal distribution or the normal data set. There are measures of data center, or what's called measures of central tendency. And then after we describe the center, we need to be able to describe the spread or the variability in the distribution. And these are called measures of variability or measures of dispersion. The most common measures of central tendency used are the mean, the mode, and the median, while the most common measures of variability used are the range, standard deviation, and variance. Before we discuss how Microsoft Excel or other softwares may be used to perform these descriptive statistics in a very short period of time, let us go first and quickly review these descriptive statistics. Let's start with the measures of data center or the measures of central tendency: the mean, the median, and the mode. The mean is the arithmetic mean, and it's simply determined by the sum of all values divided by the number of values or number of observations. The universal symbol for the mean or the arithmetic mean is X bar. So we need to get familiar with this symbol because we will use it a lot. X bar implies the mean of a sample or the average of few observations taken from a sample. It's again the sum of all values or the sum of observations divided by the number of values. And that's what this mathematical symbol means. You can see here this is a sum or the additive sum, and it goes from 1 to n, meaning that we have n observations starting with observation 1 all the way to observation n, and xi implies the individual observations values, as we will see in a minute. N is the number of observations. Let's take an example and see how this equation is used. Here is a few observations, 10 observations representing the wage per hour in dollar value. And what we can do to calculate the mean value is simply adding up these observation values, 30 plus 35 and so on, all the way to the final value of 26, and divide by the number of observations. And here we have the average of wages being 31.1 per hour, and that is the mean value or the arithmetic mean. Well, the arithmetic mean is the most commonly used measure, but there are other important measures that are used to describe the center of the data. These are the mode and the median. Let us go and see how the mode and the median are calculated. Here is an example of, that's an interesting example. We have a sample of different states, and these are the gas prices in September 2009 and the gas prices in September 2008. And as you can see here, we look at these values and we can see that there is a substantial difference of the 2 years, with 2008 being higher about $1 over 2009. The mean value here is important because if I can calculate the mean for 2008 by adding up the values, the individual observation values of 2008, and divide by the number of observations, which is 9 here because we have 9 states, that will give me a 3.77 per gallon. And then if I calculate the mean for 2009, which is giving me 2.636 per gallon, you can see that the 2008 was about $1 more per gallon than 2009. But the point here is, instead of having to go through all the individual observations, the mean value give us a good summary of the, or description of the center of the data in each year. Now, the median. The median is the value that if you arrange all the observations in the order of magnitude, it will be the middle value, or the arithmetic mean of the two middle values in case we have an even number of observations. So if you can go from the lowest to the highest value, you will see that the median is right in the middle, splitting the number of observations into 50 higher and the 50 lower. Let's take an example here. Here is we have a set of observations. This is an odd number of observations. And in order to calculate the median of this set of observations, all what we have to do is arrange the values here in ascending order, in the order of magnitude. So we start out with the lowest, going to the highest, as you can see here. And when you do that, you can see that the number or the value 16 is the value right in the middle, and that is the median of this set of data. Now, if we have an even number of observations, we will see, like this one here, we will see that if we arrange the data in an ascending order, that we will have actually two values in the middle instead of one value. And in this case, we calculate the average of these two values, and that will become the median of this data set. In addition to the median, we have the so-called the mode. The mode is the value which occurs with the greatest frequency, the value that occurs the most in a data set. If we look at this data set here, we will notice that the value of 80 is the value that has the highest frequency. So that's automatically the mode value of this data set. Now, in some situations, the mode will not be as clear as it is in this set of data. So let's take a look at this example. We see here that if you try to find one value that's repeated the most in this data set, you may not be able to. Instead, you're going to see that we have two sets of values, values, the number 9, as you can see here, or the value of 9, and the value of 14. This is the situation that can happen in practice, and we call this a bimodal situation, meaning that we have two modes. Of course, in some situation you may even have multiple modes or more than just two modes. So be prepared to have, as it should be the case in most data sets, one mode, as in this example. But if you see that the data set exhibits two modes, then you know that this is a bimodal set, and you probably want to investigate why you have two modes or multiple modes, because a normal data set should only exhibit one mode. Indeed, if you are using a software program to calculate the mode for this set of data, it will not give you a value of mode because of the fact that there is no clear mode, or there is a bimode or bimodal situation. These are the measures of central tendency: the mean, the mode, and the median. Now we move to the measures of dispersion or variability. These are the range, the standard deviation, and the variance. And the most common measure of dispersion or variability is the range that most of us are familiar with. And the range is simply the maximum value minus the minimum value. So if we have a set of data like this one, we see that the largest number is 208, the smallest one is 200, and that means that the range is the 208 minus 200, or 8. Well, as you can see here, the range gives us the spread, or how wide the data set is. It is simple, it is easy to understand. Most people understand what the range means, yet it relies on two values: the maximum and the minimum. Meaning that if one of these two values is wrong, then the range will be wrong. This is a very important point, because in most situations we are not going to be dealing with 10 or 20 observations. We may be dealing with hundreds or thousands of observations, and in this case it is a bit dangerous to use the range, because if we have an outlier or some extreme values, that will affect the credibility or the reliability of the range value. Alternatively, we use other measures of dispersion or variability. Standard deviation is one of them. Indeed, standard deviation is the most common measure of variability, and the most reliable one that most analysts use. The way we can see or understand the standard deviation is that it is a measure of the deviation of the individual observations from the center of the data, or the mean value. Meaning, if I can measure or determine an index that give me the difference, as you can see here, between this observation and the mean, and between this observation and the mean, and so on, then I am actually, in essence, measuring the deviation from the center, which give me a good measure of variability. Let's take an example to see how we calculate the standard deviation. Before we do that, let us take a quick look at the definition of the standard deviation. The standard deviation is symbolized by the letter S, and this is the universal symbol used to indicate a standard deviation of a small sample. Remember, the X bar was the universal symbol used to indicate the average of a small sample. S, on the other hand, is the symbol used to indicate the standard deviation. And as you can see here, it is the square root of the sum of deviations of the individual observations from the average value. We square each one of these terms, and we divide that sum by the total number of observations. One point I need to make here, that if the sample size n, or the number of observation n, is less than 30, which is the threshold of a small sample, as we will discuss later on. Small sample is a sample that has a size or number of observations of less than 30. In this case, we use n minus 1 in this equation instead of n. Here is an example to illustrate how we calculate the standard deviation. We have a set of data, the same set of data we had before about the wages per hour. And what we need to do is, in order to calculate the standard deviation, is to first calculate the mean value as we did before. So here is the mean value, 31.1. And in order to follow this equation, we need to take each individual observation and subtract it from the mean value, which is the 31.1. So here is the mean value, and you can see the values here, the different values in the data set. So what we need to do is to take the 20 and subtract it from the mean value. Here is 20 minus 31.1, and we square that. Then we take the 25, subtract it from the 31.1, and we square that, and so on for the rest of the observations. Now, why we square? The reason we square each term is that if we sum up the values without squaring, we're going to end up with a sum of 0. Indeed, the sum of deviations from the mean value are going to always be 0, and to avoid the 0 sum, we have to square each term. The reason for that, you have some values that are lower than the mean and some values that are higher than the mean. So the difference between the lower values and the mean would be negative. The difference between the higher values and the mean will be positive, and the positive and the negative will offset each other and will give you a sum of 0. That's why we have to square each individual term in order to obtain the standard deviation. Again, in order to calculate the standard deviation, we calculate the mean value first, and then we take each individual value, subtract it from the mean, and we square the term, and we continue with all the values, and we sum up all of this, divide. Notice here I'm dividing by n-1 because I have a number of observations of 10 or less than 30, which we said we use n-1 instead of n. And what we have here is 7.3 per hour standard deviation, and that is how we calculate the standard deviation. The final measure of dispersion or variability is the variance. And the way we calculate the variance is simple. The variance is defined as the square of the standard deviation. So by simply squaring the standard deviation, we can obtain the variance. So for this set of data, all what I have to do is either follow the equation of the variance, taking each individual observation, subtract it from the mean and the square, and go all the way to the all the observations and divide by n-1, and that will give me the variance. Or if I have calculated the standard deviation earlier, all what I have to do is simply get the square of that, and that gives me the variance. By that, we have actually summarized how we calculate the central tendency measures, the mean, the mode, and the median, and how we calculate the range, standard deviation, and the variance, which are the measures of variability. That ends this session, and in the next session, we will show how to use Microsoft Excel to quickly perform descriptive analysis.